Welcome to flip lesson number 7 on stoichiometry, the last piece of the puzzle for sitting the assessment for part B of this standard. Looking at our mind map overview, what we're doing is this part here. We're using the mole ratio from an equation similar to how we used it for our titration calculations, and we're applying that mole ratio to find out, given a known mass of something in the reaction, we're going to look at the amount of moles that mass is, and then we're going to multiply it by a mole ratio, and then we have found the unknown amount of moles by doing that, and then we're going to convert that into an unknown mass. So the answer to the puzzle is finding out an unknown mass, and the question in the puzzle is the known mass. Okay, to start with, we will just get some practice at doing mole ratio calculations. As I said, we did touch on this doing titrating. So you simply look at the balanced equation, and these numbers before anything in a balanced equation are indicating the number of moles, and from that we can determine a mole ratio. If there's no number, then we're assuming there's 1 mole. In this equation, if you look at sodium hydroxide compared to sulfuric acid, then we can say that there's a ratio of 2 of these to 1 of these, because of this big 2 in front of the sodium hydroxide. So in other words, you need twice the number of moles of sodium hydroxide to sulfuric acid when this reaction is taking place. So if instead we were told that we had 4 moles of sodium hydroxide, and we wanted to find out how many moles of H2SO4, then we would go the unknown divided by the known times that number of moles, so times the 4. So the unknown number of moles from the balanced equation, the unknown, remember, is your sulfuric acid, because that's what we're trying to find out, and our known is the sodium hydroxide, because we know we've got 4 moles of it. So we put that into this UC ratio here, U over K, the unknown over the known. So it's 1 over 2. So basically you're going 1/2 times 4, so the number of moles of sulfuric acid would be 2. Okay, now this is quite a simple problem when it's just halving or doubling, but it's worthwhile doing the process of unknown over known number of moles when it gets to trickier equations where the ratios are a little bit more complicated. So for these mole ratio calculations, and you've got a few in your workbook, we're just going to simply use the mole ratios from the question. Now, they haven't actually worded a question here, they've simply given us an equation in red, and they've told us that the N of HCl, remember N is Nigel, it's the number of moles, is 0.5, so there's half a mole of this, and we're trying to find out the zinc chloride. So in this equation, what we're trying to find out, That's our unknown, the zinc chloride. And what we know is that there are 0.5 of a mole of HCl, so that is our known. So let's do our ratio, and that's going to be 1 mole from the equation because there's no number in front of the zinc chloride. Our known is 2 because there are 2 moles of HCl that's in this balanced equation, and we're going to times it by the number of moles of our known. So known moles equals 0.5, so our answer is going to be 0.25 moles. Okay, so now you know how to do that. You can do the mole ratio calculations in your workbook. Okay, now you've got comfortable with using the mole ratio from the equation, we're going to step it up another level, and the sort of question you're going to get is going to have an extra couple of steps in it. So here's a typical question. What mass of water is produced in the complete combustion of 2.5.4 grams of methanol according to the following equation? So what you'll notice here is that they didn't tell you the number of moles of methanol, and this is the formula for methanol here, but they told you that you had certain a number of grams. So this is saying that to start with, I have to have that known mass converted into moles. So my first step is going to be to turn the mass into moles. So we want our known mass into moles. So number 1, mass to moles. Then the second step is going to be what you've just been doing before, which is you've got a known amount of moles. You're going to use the mole ratio to uck it and turn it into the moles of the unknown. Okay, so you're doing this step here, which is what you've just been doing before. Then the third step is, because the question is saying what mass of water is produced, we are wanting to now convert that known number of moles into an unknown mass. So we're going to need to rearrange that Nessels equals M and N's equation to provide the mass. So mass equals number of moles times the molar mass. So basically now we're adding to what we already know how to do. We're adding this step here, mass to moles, before we start, and then we're adding this step here, moles to mass, to what we already know. So 2 extra steps. So for example, in this equation here, in the question, we firstly want to identify what is the known and what's the unknown. So when they're saying what mass, then that is what we're trying to find out. So our water is our unknown. And what is produced in the complete combustion, and they've given us a mass of methanol. So the thing that they've told us the amount of is our known, remember? So we can put a K above our known. Okay, so in this case, now we want to do step 1, mass to moles. So instead of 25.4 grams, we want to know the number of moles. So we use this formula and we divide it by its molar mass of 32, and we get a known number of moles, 0.794. Okay, so And so the next step is what we've done in the previous slide, where we go moles times that ratio. So our known moles is 0.794, and we're going to times it by our UC ratio, which is the unknown moles of 4 over the known moles of 2. Now here's a bit of a typo here, and it should say 4 over 2, not 2 over 4. So our known number of moles is at the bottom. So because we've got 2 moles of methanol, that's at the bottom, and our unknown number of moles from the equation is 4, so that goes at the top. So 4 over 2 is our ratio, our UC ratio. In effect, we are doubling 0.794, and our answer is 1.59 moles of the unknown. And then in step 3, we're now converting those moles back to mass using this formula: mass equals number of moles, Nigel, times molar mass. So because we're talking about water here, we're getting that known number, that new known number, or the number of moles of the unknown, I should say, and we're timesing it by the molar mass of water, which is 18, and we end up with our answer, which is 28.6 grams. Okay, this is as hard as it gets, and you've got some practice questions to do on this in your workbook. Good luck with that.